Noodle.ai's asset health application predicts equipment failures across the manufacturing floor to increase process uptime, maximize equipment remaining useful life, and reduce maintenance costs. Asset Health AI is powered by 3 artificial intelligence engines. The first is Sentinel, that is trained on trillions of data points and can sense the most likely root causes of unplanned downtime. The second engine is Precog, which measures the current state of the factory and is the only AI-powered market offering that can accurately predict the time to failure of factory equipment. The third is Pathfinder, which uses tree search to interact with operators to determine the best corrective actions to maximize uptime. In this demonstration, we will showcase 2 of our AI engines, Sentinel and Precog, to show how a maintenance engineer at a steelmaking plant leveraged the Asset Health AI application to save $140,000 on a single, very eventful day. One of Asset Health AI's user screens is called Snapshot. Snapshot provides a detailed view into specific parts of plant operations, in this case, the caster. In steelmaking, continuous casting is used to solidify molten steel, ready for shaping into a wide range of final products. A ladle of hot steel is poured through a tube into a ton dish, a reservoir that in turn pushes cooled steel through shape molds into solid strands, then ready for downstream processes like shearing and rolling. The user wants to understand if any systems belonging to the caster are behaving anomalously. So at the top of the screen is the asset hierarchy. Clicking into drill down allows her to see AI modeling outputs at any level of the caster operation. Below the asset hierarchy are failure modes. Noodle's AI models take into account the different ways equipment can fail for the caster, and that translates into 5 failure modes. The AI modeling outputs are shown in the scatter plot and the table at the bottom of the screen. In this case, the user decides to view anomalous behavior on the x-axis and value at risk on the y-axis. The user sees that segment decoupling failure is spiking, so she decides to deep dive into the data. As the user navigates through the asset hierarchy, she decides to focus on segment decoupling failures. She notices that segment 12 is spiking in terms of anomalous behavior, so she decides to prioritize that asset for further analysis. Asset Health AI has another screen called Timeline that enables users to dive deep into raw sensor data and modeling outputs to perform root cause analysis. Using the timeline view, our user can understand why segment 12 is behaving anomalously. Here, the interface details sensor signals that were used to train the segment 12 segment decoupling anomaly detection model at the bottom of the screen, as our user wants to know the set of signals that are contributing to the flagged anomalous behavior. Our user sees anomalous behavior first occurred right after midnight. She clicks into that anomalous block to understand what is happening. After clicking on the anomalous block, the user sees that current and torque began spiking around 12:20 a.m., leading to power loss in the segment. So what did the maintenance engineer do? Within 15 minutes, her team had identified the power issue and leveraged Pathfinder, our third AI engine, to take preventative action and proactively prevent a $140,000 value-at-risk failure event. A failure event that would normally put segment 12 out of action for over 2 months was solved in 2 weeks' time. 1 month later, the maintenance engineer wanted to validate that the equipment fix was functioning properly, so she decided to view our time to failure modeling output for segment 12 on the timeline screen. She saw that time to failure increased dramatically on the 15th, around when the fix was implemented, giving the validation she needs to call this proactive maintenance event a complete success. By leveraging the Asset Health AI application, one operator saved $140,000 in just 15 minutes. This is just one example of the power